Hello everyone, myself Sai Prasad, a lecturer in AhleBait High School and the Junior College. Welcome to a series of the lectures of 8th class maths. We have discussed different chapters in our sessions. Today we are going to start a new chapter, that is factorization. What is this factorization? In the previous sessions we learned what is an algebraic expression and everything. We learned how to multiply and do. Here we will do some kind of an opposite way, that is we have to find the factors of it. We have to reduce the given expression into a product of prime factors, which means which cannot be reduced more. Okay, that is for example, if I have 6x plus y into 6x minus y, yes, we know that we will get it as 6x whole square minus y square, right? This is what we did in our previous class, that is in the algebraic expression. We use the formula a square minus b square. Okay, that is what from this form to this form. This method is nothing but factorization. That is, we have to find the factors of that. This is a factor, this is a factor. We cannot reduce it further. Okay, there are different methods to form. The main method is finding the prime factors or the common factors for it. Okay, finding the common factors and simplifying it and taking common everything. These are different methods. Okay, shall we start doing the problems? Let's do. See here, these are the different things they give. He is asking us to find the common factor between these two and those three. Okay, how do we find? Before finding common factor, first of all we have to find the factors of it. Factors of it bole to tell me what are the factors of 3a? 3a ka factors are 3 into a, right? Can we write more than that? No. Next, factors of 21ab, that is 3 into 7 into a into b. Okay, now what are the common factors? Common factors are 3 and the next a, 3 into a. That's it. Is there anything difficult in finding this? No, but in the next problems, while factorizing, you should directly identify 3a is a common between both. Okay, see here also let us do 7xy ka factors are 7 into x into y, 35x square y cube ka factors. What are the factors of 35? Only prime. That is 7 into 5 into x square is x into x, y cube is y into y. Okay, now let us take common. 7 is common, x is common, 1y is common. Therefore, common factors are 7 into x into y. Is it right? Is it easy? Good. Similarly here 4x square ka factors. What are the factors of 4? 2 and 2. X square ka common, x into x. Similarly 6xy ka factors 2 into 3 into x into y. Okay, and the next 8y square x ka factors. 8 ka factors 2 into 2 into 2. Y square is y into x. Okay, that is common are 2 and the next x. That's it. Is it right? Is there anything extra in all those? No? Yes? Fine. Therefore, common factors are 2x. Is it right? Anything extra? Clear? If possible, you should be in a situation to write the common between these both, that is 2x. That's it. Here is also it is 2x. If you want to write here 2x and y. Clear? Shall we start factorizing? Let's do. Look at these questions here. He is telling to factorize this. How do we do? Firstly, taking the common factors of both and taking common from that. See here if I write 9a square ka factors 3 into 3 into a into a, right? Factors of 6ax is 3 into 2 into a into x, right? What are the common factors? 3 a, right? Anything extra? That's it. Now see here, this can be written as, I will take 3 as common. What is left in the first thing? 3a. What is left here? 2x. Done. Is it clear? This is simply a factorization. In the previous chapters we learned multiplying these both. In this chapter we will learn how to simplify this into simplest form. Okay? Can we simplify this more? No, we can't do it. This is a final form. Is it clear? Just we have to write the factors of this, take common, write in the outside, the remaining terms inside. Done. Is it right? From here I will write directly. I will not even write this. See here, 4p square 5pq minus 6pq square. Do you find something similar sounding? That is p. If you take p as common, you will get 4p here, 5q here, minus 6q square. That's it. This is one factor, this is one more factor. You can't even simplify this. This is monomial and this is trinomial. Right? Similarly, look at this. Can we take something common? 3ax minus 6xy plus 8by minus 4ab. Can we? No, right? Then check, at least you can take common from any two terms. At least. See here, from these two terms, can I take 3x as common? Okay, 6 also goes in 3 table. Therefore, if I take 3x as common, here it is, a is left, here it is. If I take 3 common, this will become 2y. Clear? Is it okay? Fine. And the next, what can I take common here from these both? 4 and b. If I take 4b as common, I will be left with 2y here, and here how much is it? Only a. Okay. Do you find these both similar? Only with a change in negative sign. Therefore, let us take minus common from here. This is again one important step you have to remember. Okay. Just interchange this. The minus will come in front. Therefore, this will become as a minus 2y. This is a very important step you have to remember in the factorization. Interchanging two terms with a negative sign in between gives a negative sign in the outside. Okay. That is nothing but minus of a minus b can be written as b minus a. If this is in the form of, we will put a minus and we will interchange this. Okay. Yeah, this is one typical form you have to remember. Now, if you observe, a minus 2y is common. So, we can take a minus 2y as common. Here 3x is left. Here 4b is left. Clear? If you multiply these two binomials, you have to get this. Clear? Right? Can we simplify it more? No, this is a final form. Done? Now, let us check this. X cube plus 2x square plus 5x plus 10. Is there anything common that can be taken? Yes. Again, let us take two terms. Let us take from these two. X cube 2x square. What is common? X square is common. Here x is left. Here 2 is left. Here if I take 5 as common, here x is left. Here 2 is left. Simply, if I take x plus 2 as common, I will get it as x square plus 5. Can we simplify it more? No, it is completely an irreducible factor, that is both are prime. Clear? Is it right how to do factorization? This was the first initial exercise of your algebraic expression, multiplying it. Right? What was the final exercise was that? That is using identities. If I have a plus b whole square, I should get it in the form of a square plus 2ab plus b square. What if I have an expression in the form of a square plus 2ab plus b square? Then the answer is directly a plus b whole square. Right? In those forms, using those formulas or those suitable identities, let us do few problems factorization, a few problems factorizing. Okay, let's do now. See here, the question given here, it is a square plus 10a plus 25. What is it? We have to simplify that in such a way that it should be in the standard identity. Can you imagine or can you expect which kind of identity it might be? Here it is a square and here it is phi square. Okay, this can be written in the form of a square plus 2 into a into phi plus phi square. Tell me which formula is this? A square plus 2ab plus b square. That is nothing but a plus phi whole square. This is the answer. Which is the identity we used? That is a plus b whole square equal to a square plus 2ab plus b square. We did from this to this. Now we are doing from this to this. Right? How do we get directly? How can we imagine? I mean, how can you expect that is the same formula? That comes with practice. You have to learn these formulas more and more times. Then only you can identify to which identity it belongs. Okay? Next, this equation. Now, let us take everything common. 36 can be written as 6x whole square. Remember this squares has to be remembered. 64 can be written as 8y square. Let us write these both first. 6x whole square. Let us put it as it is. Here it is 8y whole square. Okay. In the middle we have to get 2ab term. Let us check whether we are getting same as not. 6 8s are 48 into 2 96. Okay. That is 2 into 6x into 8y. A square plus 2ab plus b square. Is it? What is the formula? That is a plus b whole square. Is it right? Fine. Similarly, see here, x plus y whole square minus 4xy. How do we simplify? Is it a square term? No. Let us simplify this first, then we will check whether we are getting or not. A square plus b square plus 2ab. Is it? Yes or no? If you observe, 2x minus 4xy is minus 2xy. X square plus y square minus 2xy. किसका फॉर्मूला है ये? Tell me. That is x minus y whole square. Is it not easy? Yes? Fine. These are all the different simple methods to learn factorization. Clear? Shall we move on to the next method? Let's do. See here. Here he is telling 49x square minus 25y square. Are those perfect squares? Yes, right? 49x square can be written as 7x whole square. This is nothing but 7x whole square and here it is 5y whole square. Now tell me which formula we have to use? A square minus b square, that is a plus b into a minus b. Is it right? A square minus b square is a plus b into a minus b. Right? Similarly here, 6x square minus 54. Is 6 a perfect square? 54 is a perfect square? No. What can we do? Tell me how to get this. We can take 6 as common here. That is, if I take 6 as common, I will get it as x square minus 9. Okay? 6. X square minus 9 can be written as 3 square. Therefore, 6 into this is x minus 3 into x plus 3. Is it fine? Is it clear? Very good. Similarly, if you observe here this p square minus 2pq plus q square minus r square. How to do? That is, this can be written as p minus q whole square minus r square. Yes? This is a square minus 2ab plus b square, that is nothing but a minus b whole square. Again this is in the form of a square minus b square. Okay? That is a plus b into a minus b. Clear? Is it easy? Shall we do few more problems? Let's do. See here, the question here it is given as 7y square plus 35z square. Is there anything common or is it a perfect square? 7 is not a perfect square, 35 is also not a perfect square, but both have common factor, that is 7. Therefore, we can take 7 as common in both of the terms. I will get it as y square plus 5z square. Can we simplify this more? No, this itself is plus, so we can't even simplify it. That's the answer, right? Fine. Now look at this question, x square minus ax minus bx plus ab. Can I take anything common? As we did in the previous thing, let us take common from these two terms and the next these two terms. If I take x common, I will get it as x minus a, and among these both, if I take, let us take minus b as common, I will directly get it as x minus a. Okay, if I take minus b as common, I will get it as x here and minus b here. Remember from this point, x minus a if I take as common, I will get it as x minus b. We got factors. Clear? Similarly, the third one. How do we do? P square q minus pr square minus pq plus r square. Can I take something common from these two? I can take only p. From first and third, we can take pq as common. Let us rearrange it. Okay. Now tell me, can I take pq as common? Pq into here, p is left, here 1. From these both, I can take minus r square as common. I will get p here, minus 1 here. Can I take p minus 1 common? Therefore, I will get it as pq minus r square. Clear? Is it not easy? Fine. Shall we do few more problems? Let's do. See here. Here the question given here, 49x square minus 16 by 25. Just observe, all are perfect squares. So we can write it as how? 7x whole square minus 4 square by 5 square. Therefore, that is nothing but 7x whole square minus 4 by 5 whole square. A square minus b square, that is nothing but a plus b into a minus b. That is the answer. Done. Okay. Similarly, check here. Here also everything is a perfect square. This can be written as 2 into a plus b whole square minus 3 into a minus b whole square. Therefore, this is a square minus b square form. That is nothing but a plus b into a minus b. Okay, just let us multiply 2a plus 2b plus 3a minus 3b. 2a plus 2b minus 3a plus 3b, isn't it? Okay. Now let us add all a terms. 2a plus 3a is 5a, right? 2a minus 2b minus 3b is minus b. 2a minus 3a is minus a. 2b plus 3b is 5b. Is it right? Did you understand? What all we learned? We learned normal common factors, taking common, right? And the next we learned how to simplify or how to factorize using identities. Clear? Fine. This is for today. Let us meet in the next session with the more topics of factorization.